Hi, I'm Bob. Let's continue to solve the problems in Chapter 6 of the textbook Microeconometrics using Stata. In question 7, we use the user-written command drive to do the Jackknife instrumental variables estimation. There were 4 different variants of the command. We use them one by one with the heteroscedasticity robust standard errors option. We can use help followed by the command's name to look at the syntax and examples of that command. We store the results of each regression and then compare them with the GMM estimation. We use the estimates table command to show all the estimates. Notice that the number in the parentheses is the t statistic. If you would like to put standard errors in the parentheses, you should add the SE option. The results from the first 2 Jackknife instrumental variables estimators are similar to those from GMM estimator. In question 8, we estimate the 3-stage least square model and compare the 3-stage least square coefficient estimates and standard errors with those from 2-stage least square estimation. In the 3-stage least square, there are systems of 2 equations. There are 2 endogenous variables. The expenditures on medications and the decision to purchase private insurance. We specify a structural equation for each of the endogenous variables. There are unique exogenous variables in each equation. This makes both of the equations are identified. We also apply the 2-stage least squares to the instrumental variable estimation and store the results. The differences in the estimates and the standard errors are negligible. From the 3-stage least squares estimation, the purchasing of private insurance will reduce the out-of-pocket expenditures on medications, while the expectation of higher expenditures on medications will increase the probability of buying a private insurance. For the last question, we use another dataset and we investigate the effect of years of schooling on wages. The years of schooling is treated as the endogenous variable. The college proximity indicator is the instrument variable for years of schooling. We use the 2-stage least squares estimation. And then perform a test for weak instrument by using the post-estimation command first stage. The F statistic is 14.99, which is the square of the t statistic of the instrument variable in the first stage. The F statistic is larger than the rule of thumb value of 10 that is sometimes suggested. So the college proximity indicator does not seem to be a weak instrument. I could not solve the last question. Instead, I would like to show the consistency of the instrumental variables estimation by using a simulation sample. We use the setseed command to ensure that you will get the same results when you rerun the program later. We store the number of observations and the number of simulations in the global macros. We write a program called OLSIV and then use the simulate command to run the program many times. In the program, we generate the error term U from the standard normal distribution. Then we generate an instrument variable Z. Then we construct the endogenous variable Y2, which is a function of instrument variable Z, and it's also correlated with the error term U. Finally, we generate the dependent variable Y1, which is equal to 2 times Y2 plus the error term. The above is the data generating process. Then we run the OLS regression and return the estimated coefficient in scalar BOLS. Next, we run the instrumental variables regression by two-stage least square using Z as the instrument for the endogenous variable Y2 and store the estimated coefficient in scalar BIV. We use the simulate command to repeat the program 100 times. The OLS estimate is upward biased, while the instrumental variables estimate is consistent. Thank you very much for watching this video. Goodbye.